Hello. It's time for logic again. Recorded under slightly different circumstances. I apologize for that because I'm having a little Zoom trouble this week. But hope to give the same content that we would have recorded under any other circumstances. We're now moving from the kind of logic that takes sentences as their units, sometimes called propositional logic, sometimes truth-functional logic, sometimes, as in Klenk's textbook, sentential logic. Having completed our look at that kind of logic, we are now going on to predicate logic, sometimes called first-order logic. As we've done with the other form of logic, and as one does until reaching quite an advanced level of logical study, we're going to break these tasks down into translation on the one hand and proof on the other. Translation meaning, of course, translation in both directions, out of natural language into the language of logic, and out of logical language into natural language. But it's the former, going from natural language to logic, and going from natural language to the logic of predicates and quantifiers, that poses the special problems that people sometimes find difficult to achieve. It's true that once you get to philosophical logic of a more advanced kind, people spend very little time moving between natural language and the symbology, the syntax of logic. But we're not there. And we want to make sure we can master that kind of translation before we go on to practice proofs, to prove the validity of arguments as cast in first order or predicate logic. I'll add that the translation in this case is more sophisticated because, in a sense, we didn't have to translate anything within a sentence when we were doing propositional logic. The propositions are given. We just had to be aware of the connectives, and, or, if then, not, if and only if. And we could just treat any proposition, no matter how complex or how outlandish, as a single sentence A, P, right? We no longer have that luxury. We're now looking into the workings. And I don't mean the grammatical workings, but in a way that I'll try to make clear today, the logical workings of the sentences. If I give a little historical context at first, it might help to show why this act of translation into first-order logic has, or has been taken to have, philosophical significance. And if you want more along these lines, see Chapter 3 of Graham Priest's very short introduction to logic. For that matter, and as a continuation of his point, Chapter 4 of the same book, very short introduction to logic. Propositional logic, in a sense, had a history of its own. Any kind of logic that could assume sentences are true or false didn't need the further elaboration of a particular logical school. The Stoics used some parts of propositional logic. But predicate logic positions itself against and in response to the logic associated with Aristotle, the logic of syllogisms. Logic was, of course, at the heart of Aristotle's system of knowledge. About half of the surviving works we attribute to Aristotle are scientific works, especially, overwhelmingly, works of biology. And he was very concerned to provide a structure that any science could use to put together its pieces, to build individual observations and conclusions into a theory. The Aristotelian syllogism, as he works it out in his well-known logical works, is supposed to play exactly that role. The works of Aristotle include the topics, prior analytics, posterior analytics, that's the real central stuff, and some additional works. And collectively, the logical works were known as the organon. Organon being the word for tool, instrument. The idea was logic, all these logical works taken together, offered the instrument by which one could show how a theory is well organized. The logical works devoted themselves to the Aristotelian syllogism. A syllogism had two premises and a conclusion. And typically, the premises were categorical statements, usually beginning with all or some, although they could also begin with an individual name. Aristotle himself called the sentences that began with all universal statements and called the others particular. His terminology for what we're doing, for what he was doing, won't concern us now, but it is telling that he focuses on such sentences, the all sentences and the some sentences. All dogs are mammals. Some dogs are aggressive. All birds have feathers. All mammals have hollow ears. I'm not choosing biological examples at random, but because for Aristotle, the structure of these sentences that the syllogisms are about is very much tied to the biology in which they'll play a role. Okay, so because biology is so much about sorting plants and animals into species and seeing what is true in every case or in many cases, Aristotle's logic likewise attends to the sentences that begin that way. You can, as I said, you can sometimes have a different kind of particular statement, like there is a big red dog. Okay, but the standard forms of syllogisms have premises beginning all or some. The Aristotelian syllogism is also distinguished in a not so positive way by coming with a rather elaborate set of rules. Now, don't misunderstand what I'm going to say. The rules work. If you study the various descriptions of the types of syllogisms, what has to happen with the terms in the first and second premise, what Aristotle calls the middle term, whether a term is distributed, what the relationship is between all and some. And if you learn all these rules, you can indeed apply them and see whether a given syllogism is valid or invalid. The rules themselves, however, have a non-intuitive quality, even ad hoc sometimes, and certainly, whether intuitive or not, they can be quite difficult to learn. The syllogism's premises are always broken down into subject and predicate. So, for example, all dogs are mammals has a subject, all dogs, and the predicate, are mammals. Some dogs are mammals has a very different subject, namely some dogs. Or there is at least one dog that is a mammal. Some dogs are wild. There exists at least one dog that is wild. So it's got a very different subject. Nevertheless, the predicate is the same: is a mammal or are mammals. Aristotle's categorization of such sentences, in a very straightforward way, in a way that can't be gainsaid, follows the structure of classical Greek grammar, and the translations of those sentences can be sorted, again, very unambiguously, unproblematically, in accord with modern English grammar. As observations of the grammars of those sentences, Aristotle's categorizations are quite correct. Indeed, the argument is going to be, where I'm building to with this, is that it's precisely because he follows the grammar of natural language that Aristotle ends up with a set of syllogisms that are hard to structure, are hard to show the structure of, rather, when we're investigating validity and invalidity. And there are other problems. The syllogism always has to have just two premises, and the premises have to display a certain kind of form, or else the rules of the syllogism are unequipped to declare whether the resulting syllogism is valid or invalid. There are even some very straightforward syllogisms, some that common sense tells you are valid, that Aristotelian logic, for all its ornate rules, can't handle. Here's a common example. All dogs are mammals. Therefore, all the heads of dogs are heads of mammals. Well, it seems clear enough. If you're a mammal, then your head is a mammal's head. All dogs are mammals, moreover, is a categorical statement of the sort that Aristotle's syllogistic theory observes, recognizes. And yet, the rules do not allow for that very simple, very obviously valid bit of reasoning to come through as valid according to the rules of the syllogism. Now, certainly by the 19th century, I would say even by the 1820s of the 19th century, the limitations of Aristotle's logic were evident. Not only that, the need for a logic of categorical statements was also pressing. Just as Aristotle's syllogistic logic is organized to suit the needs of a science, particularly biology, a genus-species kind of science, so too, originally, the structure, the emphasis in modern logic was designed to meet the needs of mathematical science. I say this because of the real advances in the early 19th century in calculus, and more than calculus, in real analysis, that is to say, the theory behind calculus. As you doubtless know, the theory of calculus rests on the idea of a limit. It was in around 1820, it was 1821, that a limit was rigorously defined by mathematicians, by Cauchy. And you can say that for all a, let f of x be a function defined on an interval that contains x equals a, except possibly right at a. And then we would say that the limit of x approaches a for f of x equals L. The limit is L, if for every number epsilon greater than 0, there is some number delta greater than 0, such that the absolute value of f of x minus L is less than epsilon whenever the difference between x and a, the absolute value of that difference is between 0 and delta. Well, if you noticed, in stating that definition of the limit, I said this is true for all a, and I said that for every epsilon, there has to be a delta, a non-zero delta, a greater than 0 delta. Okay, delta just means the change, and for every epsilon, there's a delta. This is to say that to state the definition of the limit very rigorously, you need 3 quantifiers, what Frege is going to introduce in 1879 as the quantifier. You need 2 universal quantifiers and an existential quantifier. Now, you don't have to remember any of what I just said about the definition of limit and its role in calculus, but I'm just giving one example of how the existence of such a rigorously defined definition exacerbated the need for a really precise way of understanding for all, or there exists at least one. Cauchy worked in the early 1820s, and we get, finally, in 1879, the worked out logic that can handle this kind of definition. And we get it from Gottlob Frege, of course, with his work Begriffsschrift of 1879 that defines the quantifier. Now, although Frege's logic seems to rest only on these simple terms for all x and there exists x, let's write these down. In order to get to the point at which we can use those quantifiers, we already have to have a lot of the mechanism in place, a lot of the ways of defining the thing over which those quantifiers will range. Okay, and here we come to predicates. Now I'm just going to talk about monadic predicates, one-place predicates. Things can get a lot more complicated, but things are already quite revolutionary enough when we're talking about one-place predicate. You see, because this is, and let me just be clear on where we're going, where this all leads. This is a way of talking about categorical statements. All dogs are mammals, or some dogs are wild, without remaining committed to the structure and the presuppositions of natural language and its grammar. Okay, so we're not going to be looking at things in terms of the subject of the sentence. Okay. We're going to start with this thing that looks like a familiar idea, the predicate, but the predicate is going to be very precisely defined and it's going to be put to use in a different way. All right then. A monadic predicate is not such a surprising concept. It's a property of a thing, something that can be said about a thing. Is red, is big, is a dog. These are all predicates. They're not sentences. You can see how they're related to sentences. That is, you need something to put in that blank where the subject goes, right? But by themselves, rather than being true or false the way sentences are, right? In propositional logic, we've got sentences, and it's a property of those sentences that they're always either true or false. With predicates, it's not that they're true or false, but we would say they are true of some things, false of other things. Okay, thus X is red is true of most apples and false of most bananas, false of the Eiffel Tower, false about the city of New York. Okay, it's just false of those things. So that if you try to say New York is red, unless you mean you have a particular metaphor in mind, you are saying a false sentence by putting that particular term, New York City, into the blank of that predicate. Now, when you say, so suppose you have the predicate is red, and you symbolize that with a capital R for red, and you write Rx. X is not a word. X is red. You can't say whether that sentence, X is red, is true or false. It doesn't have a truth value. You need to say what X is, or you would need to identify the kinds of things that X is about. And so we call X a variable in logic just as we call X a variable in algebra. That's one of the little points of resemblance between logic and mathematics. They're not as much alike as observers might think. So X is red is not a statement, but it's what's called an open sentence. It gives us a way of talking about things that are red, but without identifying the particular things yet that are red. To use the open sentence, I mean, and in logic, you can never just say Rx. That's not, as it were, a line in a statement. It's not part of a proof. You need to define that variable, or more precisely what's called bind the variable, by putting it within range of a quantifier. So, again, with the same examples, here f of x, let f be red. They can be mnemonic, they don't have to be. For all x, f of x means everything is red. There exists x such that f of x means something is red, or some things are red, or equivalently, there is at least one red thing. All these are treated as interchangeable translations of the existential quantifier. There exists x, so that there exists x such that x is red can mean any of those. Again, there exists a red thing, at least one red thing exists, there's something red, some things are red. Some things and something, I hate to say, different as they are in a natural language, mean exactly the same logically. It's either at least one, if you're using the existential quantifier, or all, if you're using the universal quantifier. Either everything is red is what you're asserting with the universal quantifier, at least one thing is red is what you're asserting with the existential quantifier. Now, things get more interesting. Well, sure, that's interesting enough. But things get more interesting when we add a second predicate. And here I hope to show why I've been talking about Aristotle's logic and what difference modern Phrygian logic makes. When you have two predicates and you want to talk about the relationship between them, you might say, for example, all dogs are mammals, or you might want to say some dogs are wild. Same kinds of sentences, right? you're talking about the subject, all dogs, or the subject, some dogs, which has to be a very similar subject after all, and you're ascribing some characteristic to all those dogs or some of those dogs. Namely, if it's all dogs, that they're mammals; if it's some dogs, that they're wild. Here's how we render all dogs are mammals. For all x, dx horseshoe mx. For all x, if x is a dog, then x is a mammal. Oh, you think about it and you think, oh, that is, I had not noticed that it was, but in fact, now that I contemplate the possibility, now that I consider the reality of it and what the statement is asserting, I can see why you would use an if-then structure to express this idea. Now, what's the subject? Well, it's not clear that there's a subject of that for all x in any ordinary sense of the word. It's certainly not all dogs, because all x is not all dogs. For all x, we're saying if they're dogs, then they're mammals. So x is whatever we're talking about before we even enter into the predicates. Okay? Now, when you say all dogs are mammals, you don't ordinarily think you're asserting a conditional. Aristotle would not have said you're asserting a conditional. You're taking this subject, all dogs, and you're observing or asserting some property that's true of that subject. And now suppose you want to say some dogs are wild, or at least one wild dog exists, or there's something that is a wild dog. Again, these are all ways of saying the same thing. There exists x such that dx and wx. Some dogs are wild. At least one dog is wild. So there exists something. That's why we start with that backwards e for exists. There exists something that's got two predicates true of it. That it's a dog and that it's wild. At least one thing. There's at least one thing that's both a dog and wild. What should we call that? Call that a wild dog. Okay. Some dogs are wild. Now, at least to my mind, this is the remarkable moment at which logical form really separates itself from grammatical form. Because you could, if you were staying within natural language, if you were attuned to the grammar and syntax of a natural language, you could look at those statements, all dogs are mammals, some dogs are wild, all day long. And never would you think that they are to be shaped according to two completely different logical syntaxes. In one case, you've got a material conditional. In the other case, you've got a conjunction. Now that to me is really an astonishing development. And so you can see philosophically why, or why at least for a while, philosophers thought that the logical analysis of natural language sentences brings you to a level of understanding of what's really happening in that sentence. That's the real story, the logical story of that sentence. Okay? It's not what the grammar was telling you. The logic is telling you something different. And there were many analytic philosophers in particular, who were inspired by this fact, to ask what else we could discover about sentences in natural language of philosophical import by examining them for their logical structure. Indeed, at the end of this semester, one of the examples we're going to get to, definite descriptions, was pioneered by Bertrand Russell. And it was a breakthrough example of a logical analysis of something that, so the sentences turned out to be saying something very different from what they appeared to be saying. Sometimes people summarize this moment in analytic philosophy by saying, finally, after much effort, Bertrand Russell achieved an analysis of the word the. Well, no small thing, because the is not part of the basic vocabulary of modern logic. And so to show how the is properly used in a sentence, okay, takes some logical complexity. Again, that's definite descriptions, and that's near the end of the semester. Now, in an Aristotelian mood, modern logic can continue and does continue to divide categorical statements into four big families, depending on whether they are universal assertions or existential assertions, and depending on whether they are positive or negative assertions. These are worth recognizing, learning to identify, and committing to memory. They are the kinds of propositions labeled A, E, I, and O. So a universal affirmative is an A sentence. All A are B. A universal negative says no A's are B. That's an E sentence. All right. So all A are B, no A are B. A particular affirmative, that's type I, says some A are B, and a particular negative, that's type O, says some A are not B. Okay? Those are your four options as long as you've only got two predicates, right? It's either all A are B, all A are not B, some A are B, some A are not B. But negation makes things a little more interesting. And there's one fundamental rule of negation that you want to be comfortable with. Many more rules that we're going to get to in the future once we start working with quantifiers in logical proofs. But for now, the important idea is negation. Essentially, when there's a negation in front of a quantifier, you can move it through to the other side and you change the quantifier. So if it's not the case that there exists X, etc., then you write, for all X, it's not the case that such and such. Once the negation is inside, not when it's outside the quantifier. When it's outside the quantifier, you can't apply, for example, De Morgan's law. Once the negation has moved inside the quantifier, altering the quantifier, of course, in the process, then you can use all of the rules about negation that you're familiar with from propositional logic, and they apply in just the same way. If you negate for all x f of x, you're asserting that there exists an x such that not f of x. And the contrary is true. And again, it's more straightforward than it might first look. If you're saying it's not the case that everything is red, what are you saying? You're saying something is not red. You're not saying everything is non-red, right? After all, it's true that not everything is red. You push that through it, you get a positive existential claim. There exists at least one thing that's not red. And contrariwise, suppose it were not the case, right? The negation of there exists x such that f of x. If it's not the case that something is red, then all things are non-red. Right? Nothing is red. Now you might say, well, suppose you're saying nothing is red, or nothing is a unicorn. There are no unicorns. How do you say that? Do you say it's not the case that there exists x such that x is a unicorn? Or do you say all things are non-unicorns? You can say it either way. Almost every, well, logically speaking, every universal statement, if it's a negation, can be turned into an existential statement that is not, and vice versa. That's clear. But also in a more common sense way than you might think, a lot of statements in natural language can be rendered as either statements with a universal quantifier or with an existential quantifier. And so it's not too much of a stretch to say, just as if you had to, desert island situation, if you had to live with just conjunction or just disjunction, as long as you had negation, you could ultimately translate all statements with conjunctions into disjunctional form, or all statements with disjunctions into conjunction form. So too, if you had to only possess one quantifier, you could still assert all the things with that one quantifier that you're accustomed to asserting with both of them, right? The universal quantifier, if need be, can do the work of the existential. I mean, just in an extreme case, for instance, you could put negations both before and after. It's not the case that for all x, it's not the case that they're red, right? So if it's not true that nothing is red, then you're saying something is red. So a negation before and after a universal quantifier is the same thing as a non-negated existential quantifier. A negation before and after an existential quantifier is the same thing as just a plain old universal quantifier. Then, if you want to notice this, you can work this out as an exercise. When you negate a conditional, remember that a conditional, of course, translates right away into a disjunction. The conditional, if A, then B, translates into not A or B. So when you negate the conditional statement of a universal quantifier, or a universal statement, you negate that conditional, you're going to wind up with a negated disjunction, which is, of course, a conjunction. And where do we find conjunctions? In statements that begin with an existential quantifier, right? So too, you negate that existential quantifier, the negation works its way in, you wind up through De Morgan's law with a disjunction, and the disjunction can be made into a conditional. It really does all work out. Indeed, the big danger at this stage of dealing with quantifiers is that the theory, once you're done marveling over the transformation of logic and this way of moving categorical statements from Aristotle's syllogisms into something much different, something, yet again, I'll say it, with a logical form that has departed from grammatical form. Once you get over marveling over that, you're going to say, well, this is all very simple. It's sum. You negate the alls, you get the sum not. You negate the sums, you get the all not. But knowing that much, I just say this as a friendly caution, knowing that much does not suffice to prepare you for all translations of all and some statements into logical language. Now, there's going to be a certain amount of intuitive grasp you have to get. You have to see what's really being asserted. How are the predicates relating to one another? Practice, of course, improves that intuitive grasp. And there are just, I would say there's a guide to beginning, and then after beginning, you want to just think through what a statement is asserting. This is what so charged up someone like Bertrand Russell, right, who thought, now I have a way of figuring out what's really being affirmed by a given statement. First, you want to figure out whether this is more naturally, more easily, more pliably an existential quantifier that you'll be using to translate the sentence, or a universal quantifier. You will remind yourself, and use this reminder, you will remind yourself that if it's a universal quantifier, then the essential logical connective within what follows will be the material conditional, the horseshoe, arrow in some symbolizations. Whereas if you've got an existential quantifier, you'll remind yourself, the essential connective at work will be conjunction. Okay. Having said that, let me try a few examples. Only people who are beautiful, rich, or famous will be appreciated. Only people who are beautiful, rich, or famous will be appreciated. Now, I hope that the word only there makes you think about only if. And then I hope you recall that when you're saying only if, you're thinking about a material conditional, you're thinking about that if then, but you're also, in an important way, reversing it. And so you think, okay, we're definitely in universal quantifier territory here. If we've got to use a conditional, if we've got to use the if-then to express this idea, then we're talking about for all x. That's a sound first intuition. Now, even before we get to the logical parsing of that statement, I invite you to ask yourself, what does it mean to say only people who are beautiful, rich, or famous will be appreciated? Well, that's too many predicates. Let's just say only people who are rich will be appreciated. We'll start with that, and then we can add the other predicates later. Does it mean that if they're rich, then they'll be appreciated? Well, that may be true, but that in logical terms would be the assertion for all x. If x is rich, then x is appreciated. Not what you're trying to say. You're trying to say if x is not rich, then x is not appreciated. Or, and now I can just hear, as you hear this sentence, I can just hear the clicking sound as you tell yourself contrapositive. If they're not rich, then they're not appreciated, is the same as saying if they're appreciated, then they're rich. Okay? When you're saying only rich people will be appreciated, you're saying for all x, if x is a person and x is appreciated, then x is rich. Okay? That only, just as only if reverses the if then that you might expect to find in propositional logic, so too assertions about what large groups can only be, or which only large groups can be something, reverse the if-then order. So think how you would say this if you were saying all rich people will be appreciated, and then reverse it because you're saying all appreciated people will be rich. Now, the example does not, of course, speak only of the rich. It also includes the famous and the beautiful. Okay, so you want to know what it takes to be appreciated. Well, you have to be a person and be an appreciated person. It follows from the fact that you're an appreciated person. What do we say? That you're rich, beautiful, and famous? No, that's not what the sentence is saying. It says only people who are rich, beautiful, or famous will be appreciated. Okay. Then we can write again, we're starting with the universal quantifier, and we're asking about what people are, or we're asking what are appreciated people. They've got to be persons and appreciated. And because it's a universal quantifier, we expect to put a horseshoe there. We expect this to be a conditional statement. All right. How much of this shows up? For all x, if px and ax, that is, if x is an appreciated person, then bx or rx or fx, then x is beautiful, rich, or famous. Some paintings by Joe are beautiful but not valuable. Some paintings by Joe are beautiful but not valuable. Now you might think, if it starts with some, this is probably an existential statement. It's a statement for which we need an existential quantifier. Okay, and then if we use an existential quantifier, then we're going to want conjunction to be the connective. So already we know quite a bit. We've got an existential quantifier, and we say there are some x. There's at least one thing such that it's a painting, and it's a painting by Joe. Px and Jx. And what can we assert about such things, these x's that are paintings and by Joe? Well, there's at least one that is beautiful, but it's not valuable. But. Well, now, but sounds like a completely different kind of assertion, but it's not. But really means the same as and, logically speaking. So what do we have here? All right, we have Px and Jx and Bx and not Vx. Why those parentheses? Those parentheses inside, putting Px and Jx together and putting Bx and not Vx together, reflect the grammatical structure of the sentence. But logically, they're not necessary because, as you know, when all the connectives are conjunction or all the connectives are disjunction, you don't need parentheses like that. It's just a bunch of propositions, all of them linked together by conjunction. So you can just write the same sentence. There exists X such that Px and Jx and Bx and not Vx. All of those things are true about at least one thing, that it's a painting and it's by Joe and it's beautiful and it's not valuable. Now, what would the negation of that statement be? What if you were denying something like that? Well, you'd be saying, would you say all of Joe's paintings are beautiful and valuable? I guess you'd be saying something like that. All of Joe's paintings are both beautiful and valuable. No, you're not saying that. You'd be saying, and here's where the intuitive part of translation comes in. You have to think through, what are you actually asserting? If you were denying this, you're saying, no, you would say, if that's false, that some of Joe's paintings are beautiful but not valuable, right? If that's false, then all the beautiful ones are also valuable. I mean, right? Because the sentence is silent on the question of the horrendous paintings. Okay. It's asserting that there are beautiful, not valuable paintings. And so if you're denying it, you're saying, no, no, no. When it comes to Joe's paintings, boy, if they're beautiful, then they're also valuable. And how would you assert that? You would say, for all x, if x is a painting, and it's Joe's painting, and it's beautiful, why then, it's valuable. Now, why am I asking how you would deny that? Just to show how a sentence can be stated with both, with either, that is, an existential or a universal quantifier. For if this is the negation of this, then you should be able to negate this latter sentence and wind up with the same thing you have here. Okay? It's not the case that for all x, Px and Jx and Bx all then Vx. It's not the case for all the paintings that are Joe's it's not, sorry, it's not the case that for all things that are Joe's beautiful paintings, they're valuable. And that asserts the same thing as saying some things are Joe's paintings and beautiful, but not valuable. Are these two renderings of the same thing? Sure. And how can you see that? You drive the negation through. This becomes an existential statement. It's not the case that this, then this. You would use conditional exchange to turn this into the negation of this conjunction, or Vx. Okay? Negate that whole thing, and you would get there exists X such that Px and Jx and Bx and not Vx, which is what we had in the original rendering. In fact, it's an interesting exercise, a useful exercise in many cases, to try to imagine one and the same sentence as it would go through with an existential quantifier and as it would go through with a universal quantifier. Naturally, if it's the same sentence and you're thinking properly about this, then one of those two has to be a negated statement. Okay, but then you can try it out with one kind of quantifier in front and the other kind of quantifier, and you can see whether the two end up being equivalent to one another. Okay, we're going to leave our introduction to predicate logic and the way of translating terms of predicate logic there, because the most useful thing to do at this point is to practice lots of examples. Thank you.